The next topic we're going to cover is called the inclusion-exclusion principle. So it says a music director wishes to take a band and a choir on a field trip. There are 65 students in the band and 30 students in the choir. The number of students in both the band and choir is 16. How many students should the music director plan on taking on the field trip? So what happens here? You have a lot of different errors that students make. So one student might sit here and say, okay, let's take 65, the number in bands, plus 30, the number in choir, plus 16, the number in both. And that is certainly not the real answer. A lot of students would also just do 65 plus 30. That is not the real answer. So what's going on here? Well, let's go ahead and label our Venn diagram that we're given here. So we have music director for band and choir, right? So I'm going to do a B for band and a C for choir. Nothing wrong with that. That's understandable of what they are, okay? So I'm going to label my regions again, 1, 2, 3, and 4, like I always do, starting in the center, working my way out. And I'm going to think about what is region 1, what is region 2, what is region 3, and what is region 4. Well, region 1 we know is both. And if we read it, I'll use some highlighting here. We know the number in band and the choir, which is region 1, has to be 16. That's given to us, right? 1 second. Let me get my pen. 16. So that's 16. Now let's think about it. Region 2 represents those who are just in band. Well, if we read the sentence, it says 65 of them are in band. So 65 are in band. But remember, 65 here does not represent region 2. 65 represents regions 1 and 2 added together. So how do we find just region 2? We do 65 minus 16, and we do the 65 minus the 16. We are getting, I believe it is 49. Please double check my math. Okay. So that's 49 in that region. Then let's look at C here. C is the amount of choir. There's 30 students. Sorry, let me get my highlighter. 30 students in choir. Again, that is not region 3. Choir is region 3, right? So choir, the entire circle is 30. So that means when I add regions 1 and 3, I have to get 30. So to find region 3 by itself, I would do 30 minus the 16 that I already placed. When I subtract off the 16, 30 minus 16, I'm getting 14 people, so there would be 14 people there. Region 4 is nonsense in this case. It's people who are not in band, not in choir, and at this point in time, we don't care about them because we don't need to bring them on the field trip. So the question then becomes, how many need to go on the field trip? Well, if you agree, what needs to go on the field trip is regions 1, 2, and 3. The people who are in both band and choir, the people who are just in band, and the people who are in choir. So if we look at that and we want to add it up, we would add those 3 regions together. We'd have 16 plus 49 plus 14. And when we do that, we would end up with a total of, I'm getting a number of 79 people. So notice, if we just read the question and we jumped to the gun, we would have done 65 plus 30, and 65 plus 30 is 95. So why is it not 95 students? Well, the answer is because some students are counted twice. Which ones are counted twice? Well, the ones in region 1 are counted twice in this case, okay? The ones in region 1 would be counted in band, and those same students in region 1 would also be counted in choir. So, what's the inclusion-exclusion principle about? Here's what it boils down to. If we want to find the number of people in the band or choir, or here being one or the other or both, right? That's going to be equal to the number of people in band plus the number of people in choir. That's the 65 plus the 30, right? The 65 are in band, the 30 are in choir. But the problem is we double counted region 1, so minus the ones that are in both. So we double counted those 16 students, so we need to subtract those off. That would give us our 79 as we desire. So one way of doing the problem is by drawing the Venn diagram, figuring out the middle, and then figuring out each one of the sections individually, where you subtract off the previously placed ones. Another one is using this formula right here. If I want to know the number in band or choir, I do the number in band plus the number in choir minus the number in both, because I double counted both. Well, there's a little more formality to that. Remember, the word or is union, and when I say both, I'm talking about the intersection. So what do we have here? We have the exact same thing that we just said. This would be the number in, okay, I'm going to call A band and B choir, just to make it align with what we just did. So this would be the number in band or choir, because remember the union is or, is the number in band plus the number in choir minus the number in the intersection, which is the number in both. So the number in A or B is the number in A plus the number in B minus the number in both, however many are in both. And hopefully you remember that in of, that's the cardinality, so we definitely need to use the cardinality right there. So let's take a look at this and see why or how could that inclusion-exclusion principle help us. Well, it helps us so we don't have to create the Venn diagram. We don't have to find regions 1, 2, and 3 and then add them together. We can just jump straight into the formula. So let's give it a try. It says, a school finds that 430 of its students are registered for chemistry, 560 are registered for mathematics, and 225 are registered for both chemistry and mathematics. How many students are registered in chemistry or mathematics? So they want chemistry or mathematics. So they want the number in, I'm going to call it C for chemistry or M for mathematics. Well, according to the inclusion-exclusion principle, which is what we just looked at, the inclusion-exclusion principle, to find the number in chemistry or mathematics, we're going to take, the number in chemistry plus the number in mathematics, but remember we've double counted, so we need to take away the number that are in both. Well, that's pretty easy if we read the problem. It says 430 students are in chemistry, so that gives us that number right there, right? There's 430, plus we have 560 are registered in mathematics, so that gives us that number right there, plus 560. Then we have minus, well, 225 are in both, so that gives us that number right there, minus 225. So in our calculator, please do 430 plus 560 minus 225. Let me know what you get. Please double check my math. I'm getting 765 total students who are taking chemistry or mathematics.